Okay, so everyone here currently, is present. We have a few missing people, so hopefully they either reach out and or get a chance to review this Zoom call later on. I want to make a few quick notes here that I have regarding lab notebooks. I've gotten through the second section so far of melting point, the first one, then TLC. I'm going to try my hardest to try and work this week since when we had all the storms, all of my quizzes and tests, just like everyone else's, got pushed and crammed all into last week. So fortunately, the rest of this week, I just have like very light homework. I'm going to try and get through hopefully 2 of your lab notebooks and grade them fully. So that way we can continue forward and that you will be able to learn from the mistakes from previous lab notebooks and in order to take that information forward and do better. So it looks like everyone's doing, pretty well. Please make sure to go back and review 2 videos ago if you need any help towards the lab notebook. As well, it's on Canvas under files with the lab notebook example. Mainly the things I noticed is make sure in hazards, for the past ones, I was more lenient towards it, but from now on, I want to make sure, especially today's experiment, we're going to be doing acid-base extraction. So we'll want to make sure to list every single chemical that we're utilizing all within this lab, because it is extremely critical if we were to be performing this experiment in a lab that everyone would know the hazards associated with those, as well as please make sure to list out every type of waste as if you were in lab, if it's a solid waste, an organic waste, or an aqueous waste, just so that way you know the proper disposal techniques for safety and also for the safety of the safety people who come in and have to dispose of the waste for us. So just make sure to give extreme detail, especially that we're not actually performing this in lab. It is critical for you to understand these such that going forward, you'll be able to perform these kind of labs and understand the safety and techniques that we'll be utilizing in future labs that you'll be using or in research if you decide to pursue that pathway. So some light notes also towards the lab notebooks. Make sure if you are writing it out to write it in pen and not pencil, just so that way it's extremely legible when you take your Adobe scans. One note is that if I can't read it or if it's very difficult to read your handwriting, we're going to be reducing points from now on. So make sure to write very legibly, or if you don't have the best handwriting, to just go ahead and use Microsoft Word so that way that it'll be more legible for me and easier to grade for me. Next, so yep, we went through the hazards and waste disposal. Oh yeah, so for the apparatus section, just to make sure that you understand the difference between apparatus and machines directly, that under apparatus for all the glassware we're going to be using, always make sure you don't just list out, distillation apparatus. We need to list out the individual glassware that we'll be using within a system. As well, please make sure if there are specific sizes listed within a lab manual to go ahead and state that. Condensers can be like larger or smaller. However, within this experiment, I was fine with like if someone just said condenser, thermometer. Those are general things that are pretty uniform, like very unique size. However, things like a beaker or Erlenmeyer flask, those can really vary within a lab from very small, like 25 milliliter, volumetric flask all the way to like a liter. So those sort of things will be critical in understanding what sort of size, scale that we'll be working on within our lab and within an experiment. I was also informed by Dr. Stogie to remind everyone of the HOLA discussion and project. Please make sure to fill that out as soon as possible. Let me go ahead and open that up here real quick so I can show everyone where to access this. Moment. So under modules, go ahead and go here. It actually is also under modules and under discussions. 1 second, let me move this. Hold on 1 second. Computer's having a moment. Second. Share screen. Okay, so going down here. Sorry, my computer's freaking out right now. Give me 1 second. I'm gonna let my computer cool down for a second there. I see that it's obviously blinking, so it must not be good on y'all's end either. Give me one sec. Okay. Try one more time. Okay. Nope, still having problems. Hold on one second. I'm experiencing technical difficulties. Let me restart my Chrome and close out some miscellaneous things. Always make sure if you're ever doing a Zoom call that you have to close out some extra stuff, because sometimes it can lead your computer to have too many things open and it'll start crashing. So there is a helpful Zoom tip for everyone today on my failure. Alrighty, let's try and do this one more time. See if we get the blinks. Okay, I think we're good now. Nope, my computer's not happy today. Okay, one moment. I'm gonna restart my computer really quick just because I know this is gonna happen whenever I try and display everything. So hold on one second. I'm gonna restart my computer and then I'll just rejoin this. If it kicks everyone off, then just go ahead and rejoin, but let me. Okay. Give me one second. Sorry for the technical difficulties today. Hopefully whatever was open is now closed and it can actually let me share today. So let me just log in Canvas again really quick. Modules. Okay, let's see real quick. All right, let's see if I get it this time. Okay, we're good to go now. All right, so as you see, if you click on modules here, like usual, when you want to go access the data for the week, go ahead and scroll all the way down. You know, we're group C. You can always find your schedule here. We're back on schedule. So this week, you know, last week we did polarimeter. This week we're doing the separation of organic compound acid base extraction. And down here, the mandatory assignment, you can either access it here or in discussion, but make sure and go ahead and work on this sooner than later. At least fill out the discussion portion so that you know the way that you're heading towards. And if you have any free time during spring break, I would advise to go ahead and at least start it up so that way that you can make sure that you have you're starting it. It's due in May. Obviously here it says May 1st, but you just want to make sure that everyone is starting this up so that we're not rushing to it last minute. And I'm totally willing to help everyone out with if you have anything that's outstanding. I understand this semester has been really rough and I'm here for you to help you out with anything, even if it's late at this point. I'd rather that someone pass and just have everything turned in late than them fail over, just the turmoil of this semester. So make sure to reach out to me, get the stuff turned in. Let's get through this together. And then make sure though on this one, I cannot be forgiving towards because this has been through the whole semester. So I'm really harping on this point today that I need everyone to go ahead and go forward, try to get this discussion done. But probably by spring break or something, don't put it off till the last week of April, because I can guarantee you if you work on it in the last portion of April, you know, the grade's not going to be what you want it to be. And this is a good portion of your grade as well. And it's a good buffer too. You know, I feel like that this poster would be graded very fairly easily as long as you put in a good enough effort. But if it shows that you did it last minute, you threw it together, you have some typing errors, just like the minor little things, it'll show that it was like, you know, procrastinated for a long time. And you never want a project to look like that, especially if it's something that you're presenting, even in front of like a bunch of people. Because not only is it nerve wracking, then also you have like little errors and mistakes and you're like, oh yeah, because I did that 10 minutes ago. So, you know, just work your hardest on getting this started up, work on it maybe once a week. And then by the time that May rolls around, you'll be completely done with it and you'll be good to go. So yeah, we went through this part. Let's go ahead and go back into the modules and go forward into the separation. So this week here, the week of March 8th through 12th, this is our lab today. Let me move the screen real quick. So firstly, like usual, we will read through the lab manual, which I'll open up afterwards once we get through reading through the module. Make sure on your own time to watch through acid-base extraction. This is really critical for you to be able to physically see what's going on. So I'm going to go through really in depth the ideas, the concepts, and the reasons. However, if you watch this video, then you'll see it actually in live action, the separation of your acid or your base, you know, from your solution. So I'd really greatly advise, especially this week also, to every week I advise to watch the video so you can get a visual representation, but especially for this lesson, it'll be critical for you to see the physical action of doing an acid-base extraction on certain compounds. Of course, we do the pre-lab notebooks, so I'll go forward once we go to the lab manual section and just have a couple of our students here show their pre-lab notebook and make sure that you have it written, you know, just a slight little pre-lab like usual. Let's see, the quiz. Make sure to go ahead and complete the quiz this week as soon as possible. Just make sure not to delay it, just with everything. Try not to delay it to the last minute so that you don't rush, maybe make a quick error. If there's anything that needs to be uploaded within the quiz, double, triple check that you uploaded everything. Because I noticed that on some of the quizzes recently that there was an upload section and some people either entirely forgot to upload, some people uploaded with a two-part question, they only uploaded like the first part of the question. And so even though, yes, you did upload something, if you only upload part A of a part A and B question, you only get credit for part A. So for going forward, I'm not going to be as lenient. I'm trying to be helpful with everyone because I understand it's a very difficult semester and working through Zoom is, you know, very difficult even to understand these ideas. But going forward, you know, I'm going to become less lenient. I can't repeat myself a million times if people can't learn the lesson. And if you can't learn, then you lose the points, unfortunately. So just make sure with anything that you upload within a quiz or like lab notebook, click the link that you've uploaded, and then that way you can double check in your mind that you know that you've uploaded exactly what needs to be there and everything that needs to be there, especially if it's like a two-part or three-part section. So on the lab day, these will be the utensils that we'd use here, the apparatus. Let me see. I will look inside the lab manual as we read through it to see if there are any particular machines here. So you have your graduated cylinder, you have your different size Erlenmeyers, you have your vacuum filtration flask, you have your beaker, and make sure to also, you know, list out the sizes of these because there even are graduated cylinders that are like 500 milliliter or liter graduated cylinders. And then you have your separation funnel and your watch glasses, and then you have your spatula, and you have your plunger here, and yeah, and then they're missing here. There would be a glass pipette. But regardless, going forward, yeah, and then a Buchner funnel here on the right as well. So just kind of listing out these ideas to you. You can always, you know, utilize Google for glassware if you aren't really sure what exactly is a piece of glassware. If you see it, you're not sure, like, what is this flat disc of glass, you know, with this watch glass, then you can go online and search glassware, and then kind of just look through catalog of or common glassware, and you can search that. And that way you can actually see exactly what these glassware are called and what they look like. So you can kind of associate the two if you're ever confused with those. So of course, we're meeting here online right now. And then afterwards, make sure to go forward and complete your post-lab notebook. If you feel uneasy about any portion of the notebook, or if you review your grades from before and you need more clarification, just reach out to me by email and I can give you more of a clarification towards what you need to have within your notebook. Okay, so let me see. Okay, so we have a few more people in here now. Let me make sure I didn't miss anybody from last time. Let's see. Okay, I'm gonna just take one more here. Okay, so it looks like we have everyone now. So I want to remind everyone who came in late today, make sure that we're on time from now on. I didn't account for exactly who was late, but from now on, we need to be here at 9, maybe like 5-minute grace period. But anything after that, it would be considered tardy, and that'll be towards participation grade. Just so that way, because I know if you miss like 10, 20 minutes, 90% chance you're not going to watch the Zoom video just for the beginning section. So I don't want to have to go through and repeat myself throughout, the lesson that I'm giving here today. It's only a quick hour. Most labs would be closer to 3 hours. So, be respectful with the time, be on time, and be present for the meeting, unless you have a situation that holds you from being here at the Zoom meeting, just so that way that you can get the most value out of the situation that we have for being within the meeting. And let's see, next we will go into the lab manual. And let me get that ready. Okay. Okay, and then now I want to go ahead and check a few people's lab notebooks to make sure that we have our pre-labs written. So let's see. Today I'm gonna type out as well. Let me open up where's the chat box here? Let's see. There it is. Okay, I'm gonna type out the people who I want to see their lab notebooks today. And I'm going to try to save this chat because I know that we've had for the past few weeks discrepancy with seeing the pre-lab notebook. So if I renamed you from 3-4 weeks ago, my apologies, but I'll try and make sure that I don't just keep pulling the same people every single time. So let me pull about 1/4 of everyone. Okay, so everyone here that I listed in the chat, Trinity, Brittany, Nadia, Benica, Reina, and Alexander, if y'all can please just show me really quick the first portion of your pre-lab notebook. Okay, great. Thanks, Alex.
It says you've disabled screen sharing. Do we need that?
Oh yeah.
Show you?
Yeah, if you have yours, if you have it on yours, let me. Okay, cool.
Okay.
There you go. I should be able to go now. Okay, saw Brittany. And... All right, Nadia. Great. Okay, so scroll up right here. I just wanted to touch on something really quick for everyone. So for the chemicals here, technically benzoic acid and 3-nitroaniline would be considered aqueous waste when dissolved within the acid-base extraction that we're going to be performing. But I would also add in like / organic waste, just because it's an ambiguous situation. If you had that as a solid or in its pure form, it would be considered organic waste. But within the lesson that we're going to learn today, I'm going to explain that further. So if I was grading the notebook and I saw someone put that as aqueous and it's like within the concept of the experiment, I wouldn't take off points. But I just want everyone to know, if you're utilizing this in a lab and you're not performing an acid-base extraction, then it could be considered as organic waste. Okay, so you're good, Nadia. And I think Trinity, did you have the screen share? Okay, great. Cool. Yeah, and then just make sure for the hazards to go ahead and add in every single one of the different types of chemicals that we'll be utilizing throughout this one. But yeah, you're good to go for now. Okay. All right, great. Okay, so now we're good to go. Thank you for being prepared. Just like if we were in a lab, it'd be the same situation. You know, you'd want to have all of your pre-lab notebook completed so that way that you would be prepared to walk into the lab and perform the experiment. Let me get this ready here so we can review our lesson. Let's see, share screen. Okay, let's grab my mouse real quick. Okay, all right. So this is a very great technique in chemistry because you can actually separate certain organic compounds that are not usually able to be dissolved or soluble in aqueous systems. So this is a very critical tool for performing organic chemistry. So going forward here, it's sort of reviewing what we've already covered before, recrystallization, chromatography. As you will see here, this method involves partitioning of compounds between two immiscible phases. And the idea of immiscible is something like oil and water. Those two are immiscible. In this case, we have an organic phase and an aqueous phase that are the two immiscible phases that will be within the SEP funnel that will be separating our compounds from one phase into the other. And so as we knew before, the technique of adsorption was used in chromatography for us to be able to absorb sort of compounds onto our polar silica gel and separate them by polarity. And so going forward, extraction involves selectively removing one or more components of a solid, liquid, or gaseous mixture in a separate phase, so between the aqueous phase and organic phase. And going into this, if we were in the lab, we would be performing a liquid-liquid extraction, and it's a very common method for removing organic compound from a mixture. So what happens is, let's say that you have a mixture of compounds within your organic, either dichloromethane or ether, whichever sort of organic solvent that you're using. A good method that we can use here is liquid-liquid extraction to pull out something. Let's say you have benzoic acid in this case is what we're going to be reviewing. Then you wash it with the sodium hydroxide to pull the sodium benzoate out of your organic solution, and then you'd be left with your organic phase, and your aqueous phase would have your sodium benzoate in it. That way that you've already pulled out your benzoic acid from your mixture, and now you've only been left with what you want in your organic phase. So this is a very great technique within lab. This can also be used in biochem labs with other sort of techniques as well, in using ion exchange in order to separate that. But I'm not going to go too deep into detail there, just so that way we can understand what's happening here. All of these here are critical, and I wanted to review them with everyone here so that we understand exactly what's happening. Firstly, the extracting solvent must not react in a chemically irreversible way with the components of the mixture. What they mean by that is that some things may dissolve and decompose by chance, like the acids, for instance, from the TLC, if everyone remembers that the silica gel can be decomposed because of an acid. So that would be a situation that would be chemically irreversible, because once it's decomposed, it's decomposed. It's like when you burn food, you can't just, go put it in the fridge and all of a sudden you have a fresh, fresh raw food. It's decomposed, it's done. So that's the first, rule of thumb that we utilize in the lab. Secondly, the extracting solvent must be immiscible or nearly so with the original solution, meaning that it would separate into two phases, whether that be aqueous or organic. The two phases are immiscible, and that is a critical portion in order to separate one compound from another within two given solutions. Thirdly, the extracting solvent must selectively remove the desired component from the solution being extracted. That is, the partition coefficient K of the component being removed must be high, while the partition coefficients of all other components should be low. And the partition coefficient is relative to the concentration of a given substance within a solution. So this is effectively saying that that it must be able to pull one of the compounds out of the other phase while leaving in whatever compound that you're trying not to pull out of there. So as they pull oil out of the ocean, utilizing special chemicals or enzymes, it's the same situation. They want to leave the ocean water there, but they want to pull the oil out and get that out of the sort of ocean solution, if you will, with this weird metaphor I'm going on. Anyways, going forward, the extracting solvent should be readily separable from the solute. Use of a volatile solvent facilitates its removal by simple distillation. And so what this means is that, you want to perform your extraction and you pull what you want out. They want you to go forward with a good solvent that is able to be distilled off. So remember, in simple distillation, what happens when we take our cyclohexane, we distill it off, it boils off, and then it distills down. Well, what we're left with is our original crude mixture, right? So then within the lab, what we do is once we perform these sort of extractions, then we go forward and utilize this thing called a rotovap, and it's a rotary evaporator that performs distillation of solvents, and it pulls the solvents off from your glassware, and it leaves you with your pure compound because all of the solvent has been pulled off. So this is just saying we want to make sure to use a solvent that is readily separable. It can be taken off of the solute or taken off of our pure substance, so we can just be left with a pure substance alone, and we can get rid of the solvent that we'll be utilizing. So going forward, we're going to be understanding the conceptual difference between acids and bases, and you can review the pH chart in order to understand the difference between acid, which is a low number, and base, which is a high number. They vary on a scale, from 1 to 14. So as I say here, most organic carboxylic acids are insoluble or only slightly soluble in water, meaning that if you tried tossing that into water, then it most likely would not dissolve entirely. 1 second, I'm gonna go close the door real quick. Okay, now, so knowing that organic carboxylic acids are insoluble or only slightly soluble in water, then we can go forward to understand that the compounds are highly soluble in dilute aqueous sodium hydroxide because the acid is deprotonated by the base, producing the sodium carboxylate salt. So as an acid, as an organic carboxylic acid, it can be deprotonated by a base, as we know from like Gen Chem, that bases and acids, they react together to form water and CO2. And so here we can understand that benzoic acid is insoluble in water. However, it's highly soluble in organic solution. However, if we were to utilize a sodium hydroxide solution to extract it from the organic solution, let's just say dichloromethane is your solvent, and you have benzoic acid dissolved in dichloromethane. If you were to wash that with aqueous sodium hydroxide, what would happen is it would actually go ahead and deprotonate your benzoic acid, which is not water soluble. It deprotonates it and creates sodium benzoate, which is highly water soluble because it has your sodium ion there. So going forward, the aqueous layer would contain the carboxylate salt that can be separated from the organic layer. So your organic layer of dichloromethane, in this instance that I'm giving, would have no longer any of the sodium benzoate. You'd have it into the aqueous layer. And then finally, you can take your aqueous layer aside and acidify it again with hydrochloric acid, causing the sodium carboxylate salt to convert back into the carboxylic acid, which again, not water soluble, so it would precipitate out of solution. So you can separate it, put aside your dichloromethane, then you have your aqueous layer that's basic and it has your sodium benzoate in there, cool it on ice, and then add in hydrochloric acid. Then the hydrochloric acid reprotonates the sodium benzoate, and then sodium chloride is produced on the side, and then benzoic acid precipitates from the solution because benzoic acid is not soluble in aqueous systems. It's only soluble when it's deprotonated and created into the sodium benzoate counter ion. So we just need to understand the main concept of that an acid can react with a base in solution in order to become water soluble. And then if you put acid into the solution and you make the solution acidic again, it'll precipitate out back into the acid form, in this case, benzoic acid, which is not water soluble, it's only organic soluble. Then in the counter idea to this, talking about organic bases, well, amines in this situation, just remember the NH2, amines, try and remember these key words. These are insoluble in water and can be separated by extraction with hydrochloric acid. So since the organic base, we're taking the opposite viewpoint, right? Our base is this amine, and we can add in hydrochloric acid to actually go ahead and protonate the amine and create the ammonium salt, which is very soluble in water, but not in organic solvents. So you can kind of see the direction that we're going here and what we're going to do going forward in this separation of the acid and bases. So you would know firstly that the organic acid, not soluble in water, if you put sodium hydroxide aqueous solution of a base in it, then it'll become soluble. However, if you have your amine in there and the aqueous solution is very basic, then the amine wouldn't dissolve, because the amine can only dissolve when it's protonated by an acid. So you can see the two differences there. The amine will only be soluble in acidic conditions, and then the benzoic acid will only be soluble in basic conditions. So that is the main concept that you have to understand here, is that the amines will be soluble in aqueous solutions in acidic situations, and then the organic acids will be soluble within basic situations. So going forward here, you can see the 3-nitroaniline. You can ignore like the nitro group. That's just so that way you don't get too clouded on so many images. I know that looking at organic chemistry can be daunting. Sometimes you see a lot of structures and you're like, oh my gosh, what is all of this? It's a benzene group, it's a nitro group, but those are not the important thing. What the important thing is here is this amine. This amine gets protonated by the hydrochloric acid in order to create the ammonium salt, which is water soluble here. And as you can see, nitroaniline, not water soluble. It's like an oil in the lab. But then once you protonate it into an acidic aqueous condition, it becomes water soluble and it can actually dissolve into your mixture because it goes into its salt form, the ammonium salt form. And once again, just like before, when you can deprotonate your organic acid to create your sodium benzoate, you can reprotonate it by adding acid. Well, the reverse is true for your 3-nitroaniline. After you've acidified it and made it water soluble, you can go ahead and turn around and basify it and make it not water soluble once again. So remember, amines, they like the acid and it becomes water soluble in acidic conditions. And going back up here, the organic acids, they like the base. So in basic conditions, they become water soluble. And they always, once you switch back from basic to acidic, they will either become soluble or insoluble. And that will allow you to either dissolve your organic compound or precipitate your organic compound. It happens one way or the other. And as you can see, they have opposing situations there. So utilizing your understanding of these properties, you'll perform the separation of a mixture containing benzoic acid, 3-nitroaniline, and a neutral compound, which is naphthalene. Naphthalene here is this like dibenzene ring combined together. And as you can see here, the key difference that I want everyone to take home today is that here, naphthalene, there's no amine, there's no acid, no carboxylic acid present on this compound. So what's the take home idea? No matter if you react it with strong base or strong acid and you're performing a separation, the naphthalene will always be in your organic layer, no matter what, because it doesn't get protonated, it doesn't get deprotonated, it doesn't react with either of them. So what we can do is, we can utilize these techniques in order to separate out your benzoic acid and your nitroaniline, and then finally you would have your organic mixture of just the naphthalene left over. So going forward, you would separate a mixture containing benzoic acid, 3-nitroaniline, and naphthalene, calculate your percent recovery, and then measure the melting temperature to make sure that you have pure compound. So I'm not going to go step by step here because everyone knows, this is what you're going to be performing in your procedure. Make sure to word it in your own words as best as you can. I know it's very difficult with the fact that you can only say things so many times, so many different ways. Just try to reword it as best as you can, and make sure to list out every single chemical this time around. I will make sure that I will be taking points off if you don't list out every single chemical, especially in this situation. Benzoic acid is dangerous. Aniline, not as dangerous, but still corrosive to the skin. Diethyl ether, it is a lung hazard. It can potentially be a hazard to your system, your central nervous system, if you were to inhale too much of it. These things, they can be dangerous. And unfortunately that y'all don't get to experience them in lab, it comes with the idea that we still need you to understand the hazards and associated risks with these chemicals, just as if you were going to be performing this in lab. So make sure to list out every single step here that is within the procedure. And then your post-lab questions, make sure to have those at the end, and give a good detail in your conclusion as to what you've learned from this experiment and why it's important and how you can maybe utilize this in the future if you perform research or within a chemistry lab within the future. So make sure to go forward, answer out all of these post-lab questions. And this is a great chart here. This is exactly the idea that we're going to be reviewing, okay? You take a solution of your mixture dissolved in diethyl ether. You have your aniline, which is your amine, your base. You have your benzoic acid, which is your acid, and then you have your naphthalene, which is just your neutral organic compound, right? You place all of this into your SEP funnel. You add in 15 milliliters of hydrochloric acid and extract. Well, what would be pulled out of the hydrochloric acid? We would see that the nitroaniline would be converted to an aqueous salt. So knowing that, we have an aqueous layer and an organic layer. We'd have two layers, just like oil and water. So on the side, you'd have your hydrochloric acid extract. So I'm going to go ahead and go forward with this left side so we can just kind of, let's just say that you're performing this experiment and you have your hydrochloric acid extract on the side. Your nitroaniline is now the ammonium salt dissolved in hydrochloric acid. Put it onto your ice bath, then slowly you neutralize it with sodium hydroxide, and the 3-nitroaniline actually comes out. Then you can vacuum filtrate it and then obtain a good salt, and then you could dry it in an oven, perform your percent recovery to see how much that you got out from your beginning amount that you dissolved in there, how much did you get out? And then finally find your melting point to see how pure it is. Then come back, you have your organic layer still, right? Well, you put it back in the SEP funnel, and then we're gonna go ahead and use 15 milliliters of sodium hydroxide this time. So what happens here? Well, remember, the benzoic acid converts to the sodium benzoate. So the sodium benzoate dissolves into your aqueous layer, and then you can set aside your aqueous layer with your sodium hydroxide extract. Again, cool on ice bath, then neutralize it with hydrochloric acid until you see the benzoic acid precipitate out, vacuum filtrate it, dry it in the oven, and then once again, find your percent recovery and melting point. And then your organic layer, well, it says here to discard the organic waste container, but as we know, in the organic layer, you'd have your naphthalene. I believe that they don't have an adequate way of performing the removal of your solvent in order to recover your naphthalene, but primarily you would put it onto a distillation apparatus or sort of a rotovap in order to remove your solvent, and then you'd be left with just your naphthalene because you've already pulled off your 3-nitroaniline, you've already pulled off your benzoic acid, so the only thing left would be the neutral naphthalene because it has no benzoic acid on it and it has no amine group on it. Neither way can be protonated or deprotonated. So yeah, that's where we're going to be ending today's lesson. If you have any further questions, please feel free to go ahead and ask. And otherwise, I'm going to go ahead and stop our recording here.